Today I'm going to show you how to make a boot dryer, and that's the contraption sitting here beside me. I just made this out of scraps I had here in the shop. Of course, I'm a bit of a pack rat, so I had most of what I needed here already. I had to buy a few odds and ends for it, but for the most part I had most of the stuff here, so it didn't really cost me anything. I just had a little bit of time into it. And the boot dryer doesn't need to be made out of oak like this one. It can be made out of anything. This is a more of a practical device, so you can make it out of whatever you have laying around. It does not need to look nice. It just needs to work. If you work outside, you know what it's like to have damp boots. If it's 15 degrees outside and you need to plow snow, and you put boots on in the morning, that you figure already your boots are damp, and they're what, 68, 70 degrees, whatever room temperature is in your place. So they're 30 degrees colder than body temperature, and you're putting these on, plus they're damp, which even draws away even more body heat. And then you go outside, even if your boots are insulated, you go outside into even 30 degrees or 20 degree weather. That just makes for a miserable day. You can also buy these, of course, and they're not much money really, but if you want to just build one of these yourself, there's a little bit of satisfaction in that, especially if you can build it for next to nothing. Go for it. Alright, here's the materials I'm going to use for the boot dryer. This is just some oak I had laying around from another project I was working on last winter. And so I decided to use, some of these odds and ends I had laying around here. This is 3/4 inch, and it would probably be better to have something thicker, at least 3/4 of an inch thick, if not thicker. It's just easier to work with, to fasten or glue, whatever you're doing. This is 12 inches wide here, but I'm going to be cutting these pieces down. Also, I have this miniature lamp holder. It's a standard size light bulb base, but I say it's miniature because the footprint of the base is actually smaller than a regular lamp holder. So that's that. And a tubular lamp also. You can use a spherical lamp as well, but I'm using the 25 watt tubular like they used to use in the fish tank aquariums. I think they still use them, I'm not sure, it doesn't matter. But this is your run-of-the-mill extension cord, 16 gauge, fairly light duty. I'm going to be cutting the end off of here and then splicing in an inline switch right into this line right here. So I won't have to cut into the box and put a switch right in the box. It just saves that step. Moving along here, I have a piece of PVC 2-inch drain pipe, and this is going to be the vertical boot support. There's no other way to describe it. It's going to be just a boot support. At the top of the boot support is going to be a form that's used to hold the boot at a certain angle and allow air circulation in and out of the boot. I might be using automotive carpet on the pipe too around it to make it look a little bit more finished, because PVC looks like rough construction, and if you have something made out of oak you might want to finish it with a piece of PVC just to make it look nice. Alright, I have the boards cut now. I don't have anything fastened yet. It's just everything's just loose. I just set it up so you can see what it looks like so far. The next step now is to figure out the spacing for the PVC uprights. Of course, they're going to set up. Whoops, almost took the ceiling out. They're going to sit on there like that. Now I have to figure out the hole spacing, so I'm going to use these couplers here to kind of figure out, to do the layout on top of here. Okay, I'm going to grab a piece of pipe here and check this real quick. It's a little tight, but that's a good fit there. No real big gaps in it. Fits pretty nice. That'll work. At this point I have a few more boards cut. As you can see, I took some 2x4s and ripped them down into 1.5 by 1.5 and made sure at least two of the sides were right angles to one another, so you got a good accurate joint here in the corner. and that will ensure this box actually stays square from top to bottom. Keep in mind I'm not a cabinet maker, so I'm not going to be using any sort of involved joining methods like biscuits or dowels or dovetails or anything like that. I just have simple equipment to do this with, so I can't get real fancy with it. I think I better take this outside. Next thing I need to do is mark positions for the vent holes. As the warm air rises, it has to be replaced by something. So I'm going to put a few small holes in the back side of this just to let in a little bit of fresh air. I put pilot holes in here to begin with because drills tend to follow other drill holes, and otherwise it might walk around if you don't have a drill press. And I'm not setting this up in the drill press because my drill press has metal shavings and other nasty stuff I don't want on this finished piece. So anyway, these drill bits are very sharp and they tend to grab in wood and plastic. So what I'm going to do here is I'm going to start this with a step drill to get down into the wood, so this will be less likely to splinter outward, because that would be not good at all. Nice thing about these step drills is they have a built-in chamfer between each step, so that chamfer will give it more of a finished look too. I'm going to bring this cord in here and see where I want to position it. I'll go ahead and assemble this. So let's go ahead. Okay, that was a mistake. So let's go ahead and get the lamp holder here in position. One of the disadvantages of using a light bulb as a heating element is that the light bulb is giving out most of its energy in the visible part of the spectrum. And visible light is not going to dry anything. What you need is to be able to convert that visible light into infrared light, also known as heat. And one of the best ways of doing that is to use flat black paint. Now, flat black paint, it has to be flat because you don't want to glare or gloss on it, because any reflection you get you realize is visible light escaping, it's coming back out. Flat black paint, and you want black too, because black absorbs, the reason it's black is because it's absorbing all the colors of the spectrum, and it's absorbing them and not releasing them. So when that energy is absorbed by the black paint, the energy has to go somewhere, and it comes out in the form of heat. So what I'm going to be doing is coating the inside of this boot dryer enclosure with flat black paint. The type of paint I'm going to be using is stove paint, flat black stove paint. I like that because it's heat resistant and also it dries quickly. You ever notice when you go to spray paint, a hurricane comes through? Just about every time. Now while I'm at it, I'm going to also give it a clear coat with some polyurethane spray. Here's what I come up with, right there. This fit right down in the tube like that, just like a little foot. Only it goes that way. Last night I decided to test this unit just to see if there's any unforeseen problems. You know, being it's a new design of mine, I just wanted to see if there's any kind of safety hazards or just to make sure it works the way it's supposed to. Unfortunately, I did find a couple issues with it, and I wanted to get these settled before I finished the video so you guys would know about it in case you want to build your own. The first issue was, as you know, I put this in the bottom to seal the unit, to seal the heat into the unit so the heat wouldn't get transmitted to the floor. Unfortunately, what I was finding was this was still getting pretty warm, not burning hot. I mean, it wasn't a safety hazard, no fire hazard or anything, but it was getting warm enough that you could feel it, and it was actually making the top of my workbench warm too. So what I did, the easiest solution I could find was to glue some of this bubble wrap insulation. I'm sure you've seen this in the home improvement centers. It's very efficient. So I used that and fired it up again and found this didn't get warm after that. So that problem was solved. I was happy to see that. The other issue I had with this was I found out that I had some differential heating issues. That is, for whatever reason, one of these tubes was getting hotter faster than the other tube. What was happening though is this one tube was drawing the hot air up through the tube, and not only was it coming in through the vents in the rear of the housing, but it was also pulling cold air down the other tube. And I couldn't stop it. I couldn't get it to stop doing that. And like I said, I don't know why it did it. But the only way that I think I can solve this is by partitioning these two tubes, isolating them from one another, from airflow, or most of the airflow, and then moving this lamp over here and adding another lamp on this side. So you have two separate heating units. And not only should that solve the differential problem, but I'm thinking that it will double the amount of heating capacity too. Instead of being 25 watts, it's going to go up to 50 watts, which still isn't a huge amount of power consumption. It'll just mean your boots will be drier faster. It is finally finished. The moment we've all been waiting for. At least that I've been waiting for. It turned out decent. The best part about it is it actually works now. Since I did that partition modification that I showed you in the video and added another light bulb, I am now getting equal heating on each stack. I'm getting 90-degree output on each at the top of each tube now. And it's 65 degrees here in the room, so I'm getting a 25-degree increase. That's not too shabby. So I'm real happy with that. So pretty much, you know, it's a boot dryer. Not much else to say about it. I can explain how this works. There's an angle here. When you hang your shoes on here, what it does, of course, is hot air rises and goes up into the toe. As it dries stuff out, there's a natural convection, a circulation. As the air cools down in the toe, it naturally drops back down and comes out of the shoe to be replaced by more hot air. And that is how it works. Powered by light bulbs and black paint. Pretty much that's it. So it's not getting hot. It's been plugged in now for about an hour, maybe an hour and a half. And it's warm to the touch, just a little bit over body temperature. This is body temperature pretty much on both sides. Tubes are, you know, you can't really tell with that automotive carpet. I didn't like the PVC tubes sticking up by themselves. It just looked like raw plumbing or raw construction out of a piece of oak. And it just seemed kind of weird to have a finished piece of oak with pieces of raw PVC coming out. So I added the automotive carpet. I think it looks decent, plus it added some insulation value to these tubes too, will help the efficiency. And of course this is a finishing look there too, it made it look a little bit more mechanical. I wanted to use brass, but I didn't have it, I just had aluminum. So I think it looks decent, it turned out good. So anyway, I have a lot of editing to do now, probably at least 5, maybe 6 hours editing. There's a lot of scenes, a lot of stuff I had to do over on this. It ended up being more complicated than I thought it was going to be. So that's why I'm a little bit late putting up this video. But I do appreciate all the thumbs up and all the comments you guys write and all the new subscriptions I get. It's really great. I've been getting a lot over the summer, so thank you for that. Okay, with that being said, I will be seeing you next video.